Hello, Keith Rucker here at VintageMachinery.org. Guys, today we are back to work over here once again on the Stoker engine that is continuing to give us trouble getting these slideways machined down the bottom of this. It's been a super challenging part for me. Been working on it off and on for quite some time and still have not come up with the perfect combination. Trying to do it over here on the metal planer, and I've had some success. I've actually been able to do some roughing and get it at least roughed out on one side here. But when I went to do my finish cuts, the planing cuts, I ran into some problems where the cutter was just digging in and gouging in. I want to just slow down here a minute and kind of talk about the problem and talk about some solutions. And yeah, you guys have sent in a lot of comments, a lot of emails, a lot of messages and whatever with suggestions and whatever, and I greatly appreciate it. But before we get too deep into, I'm not going to go through and analyze each and every one of those, but we're going to probably try to address a bunch of those comments and stuff in this video. And yeah, the problem is that a lot of the simple solutions aren't so simple in this particular application because of the problems that I've had from day one on this part is that I've got very constrained area that I'm working with. I'm working down in a hole basically. And probably my biggest challenge that I have is that no matter what kind of tool or cutter that I'm using, when you get to the front edge of this slideway, I've only got an inch clearance before I run into the front of the whole thing here. Even when I was trying to do this with end mills on a milling machine, you know, I was basically restricted to a cutter that had to be smaller than 1 inch in diameter, or 2 inches in diameter, I guess, to be able to come out and clear the front of this, where the side was still cutting before it ran into the front. So, you know, I was dealing with basically like 1.5 inch diameter end mills, which sounds like it's big until you got one that's this long to be able to reach down in there. And it doesn't matter how rigid your machine is, you just got a certain amount of flex in that cutter when you're only working in the very bottom of the hole. Same thing with the metal planer here. My problem that I've got is the length of this cutter that goes down in here. You know, anytime, just like you use a lever, when you push down on a lever, you have more force pushing down than, you know, you can pick up something heavier when you push down with a lever because of the length of the lever coming out. Well, this is basically a lever, so the force that is down here in the bottom of this is pushing on this. By the time it gets up here, it's multiplied, and what's happening is things are bending. Even though I've got, what is this, a 2 inch by 1.25 inch steel shank holding this thing in here, very rigid piece of metal, when it's, you know, 18 inches sticking down in here, it's going to flex a little bit. And then you got the whole mechanism back here that even though this is pretty much as tight as I can get it with the gibs and everything else, this machine was scraped in. It's a tight machine, but there's a certain amount of flex that's going to happen all the way back up into the whole part up here. Although most of the problem is the flex in this shaft right here. That's where most of it's happening. So again, let's let me get in here and kind of show you the front edge of this, just so you can kind of see what my challenge is, because this is where everything becomes a problem. So to start off with, let's just look at some of the constraints here. This cutter that's coming in here, when I come in here and put this up to here, I mean, right now I'm at 1.5 inch clearance before the side of this tool is hitting the side of the planer, and it's not even all the way over. So really, by the time I get my tool over, I've only got 1 inch clearance on the side. Why does that matter? Well, people have been suggesting, hey, just get a die grinder and stick that in there. Well, the problem is that by the time I have a shaft that comes up here where the die grinder's up here where it will clear because it's got a certain diameter to it, then you got all the flex in that shaft of that grinder turning down here in the bottom. It's just not rigid enough. It's too long, spindly of a part to fit down in here, and I don't have a die grinder that's small enough in diameter to be able to get down here and grind on this. So I've had some people suggest, you know, using a tool post grinder, which I've seen done. You turn your planer into a surface grinder, but again, there's not room down here for a wheel to be turning in the bottom of this or even on the side of this. And when you get up to the front, I've only got 1 inch clearance, again, from the bottom of this to the top, so the maximum wheel diameter that I could turn would only be, 2 inches, and that's pushing it. And there's not enough, by the time you look at where the center of your shaft is, you can't get deep enough in there to do it. I got to have a wheel that is at least 4 inches in diameter, because there's 2 inches where the center of the hub would be to clear the top of the ways. And if I got a 2-inch diameter wheel, well, guess what? That's 2 inches right there, a 4-inch diameter wheel. It's hitting all this. There's just not clearance in here to be able to do a lot of stuff. And that's what's been giving me trouble on this from day one. Again, even the end mill's coming down in here. You got an end mill that's 1.5 inches in diameter, and it's barely clearing the front up here by the time you cut the sides. It's just a challenging part. So let's talk about, though, what the actual problem that we were having going on right here is. So first off, this setup worked pretty well when I was using a cutter like this down here in the bottom that had a fairly small radius. So you got a fairly small area of engagement into your work. And yeah, there's a little bit of flex going on in here where it's, not the smoothest finish I've ever seen, but we were going to try to clean it up with a planer tool, which is a flat bottom tool that you use on these planers to do things. The problem here is because this is so wide, it's putting exponential forces onto the cutter. So even a tiny cut is causing this tool to bend, and when it bends, it's digging into the piece down here in the bottom and catching. So this is a common problem with planer work or even on a shaper, and there are solutions to that. And the biggest thing you can do is you can actually put some type of spring tool in here so that when you get too much flex, your tool just flexes back, it hinges back and goes out. But there's your geometry of how that thing hinges is extremely important. And I'm going to take you over and show you in a book, because it really illustrates this pretty well, the problem that you run into as far as when that tool is actually flexing and bending. So if you guys watch my odds and ends videos, you see people sending me old books and stuff all the time. I talk about how I love these old books, and particularly related to machine shop and steam and what have you. And I do reference them quite frequently. This is a book that I've got. I don't even remember where I got it from. It's called A Treatise on Planers. And it's all about using metal planers. And in this book, there's a nice little diagram here that kind of shows the type of some different options and tooling, like for planing cuts, that you can do, and what some of the problems are, and why a spring type cutter can help you out here. Let me zoom in a little bit closer. So this first illustration is kind of exaggerated, but if you notice, you got the tool coming down, but your cutting point is well in front of it. Now, it's assuming that the pivot point of this whole thing is going to be the hinge of the clapper box. Now, you could argue that if you got flex in your cross beam and all that, it could be even farther back than that, but that's a good assumption point, is that's where things are kind of rotating from. Well, if that cutter is way up here, basically if you swing an arc on that, if you swing a radius around that, draw a compass or whatever, you got this line right here. So if that thing catches, guess what? Boom, it's going down into the work. It is digging down into the work. And that's basically what was happening over here with me, is because my cutter is in front of the pivot point. The pivot point is actually behind the cutter. So if you go to a cutter like this, which now you look at where the pivot point is directly behind that. If this part catches, what happens is instead of digging into the work, boom, it's actually swinging up out of the work, so it doesn't gouge into your work. So this is a way that back in the day that they got around the very problem that I'm dealing with. So you needed to have the cutter behind the pivot point. And that way, if it does catch, it will swing out of the way rather than into the work. And the way that this was accomplished in reality is you could do multiple things. You could have a little S hook like this. I've seen some old planer, some forged planer cutters that kind of look like that. With modern tooling and stuff that we use, high-speed steel cutters and stuff like that, it's not as practical, but we can still kind of work with that general concept to come up with a solution. Let me show you a couple of other cutters that I have in my collection that kind of take this principle, maybe not this exact example, but this whole principle and put it into work. So let me show you some of these. So first off, here is a cutter, a tool holder. This is something that a viewer sent me at some point in time, and it's something that I actually would like to adapt. Now, it's missing its cutter. I can make a planer cutter to go on there. I just need to get a piece of tool steel and grind it and do it. But if you look here, you got where you connect this into your part or into your holder, but this little piece comes behind it, and you got actually where it can actually flex in the tool itself. So this thing here has got the ability to flex in there. Plus, it's putting the cutter farther behind it, closer to that pivot point that we were talking about before. But in this case, you actually have your part where it's plenty strong enough to do the work, but if something's going to bend, it's going to give right here, which again will cause that cutter to come back behind its work, because now your pivot point is really kind of back in here. This is where it's going to be pivoting from, is that's the weakest area in there. So, this is an approach that you can do it. They call this a spring type tool. I've seen many different variations of this design over the years. I don't have very many in my collection of tooling, but this is one example that I have. The problem, well, why not just use this tool? Well, the problem with this tool is that because of where the shank is, again, by the time I put a cutter in here, I've only got an inch clearance before I run into the front of that, run into my part over here. So even if I put a cutter in here, there's more than an inch before I run into that wall, and this is going to crash into the front. So this tool I couldn't use. Now, if the shank was kind of behind it over here, or anyway, you could adapt it to make it work with a different hole setup, or with this type of spring on the bottom, but you'd have to have a different setup to do it. And I've got an idea how I can do that. But anyway, just an example. Here's another one. This is actually a tool for cutting like gear teeth, or threads rather. And this probably would have been used on a lathe more so than on been used like this on a lathe to go in there and feed, but it's the same principle. You got a flex point right here. This is your cutting point right here, but you got a flex up here. So if something gives, it's going to give back here. This is going to collapse back, and your tool will give. Now again, I guess this is a lathe tool, not a planer tool, although you could use it on the planer if you were needing to cut, something with a point in it like that. It could be used on a planer, but it has a spring action in it to give some relief. So, there are some examples of some things that we can do. Let me show you some of these other planer cutters that I have. So another common type of planer tooling that you run into is this type of a tool holder. And I've got these in multiple sizes for planers and shapers. I've actually used this one before. I've actually got a planing cutter in here right now to be able to plane with. But basically on these, you got a screw that comes through here, and these have little indexes in there where you can move it straight across, straight up and down, or at 45-degree angles, and you can move your piece of high-speed steel around to wherever you want it. I think I'm going to kind of use this model here, or this type of tool holder, in what I'm going to build to try to fix my problem over here. And I'm going to kind of sketch it out and kind of show you what I'm going to have to do. And again, this whole setup that I'm doing, I'm going to have to make a cutter to fit this particular machine. And it's probably not the most ideal solution to the problem, but it's dealing with the constraints that we talked about before in this particular machine. So let me kind of give you an idea of what I'm thinking. All right, so I'm just going to make a little illustration here. This is kind of the clapper box on my planer. Rough drawing, I'm not an artist, but this is what I'm kind of looking at. I really want my cutter to be behind the pivot point of the clapper box instead of in front of it like it is now. Now my cutter goes straight down and my cutter's way out here in the front. So what I'm going to do, I think, is make a shank that will come in here, and it's going to kind of bend around and then come back down here on the bottom kind of like that. And then I'm going to make a little adapter here on the front that I can put my tool steel into and make a cutter down here in the bottom. And there'll be a bolt here on the back that will tighten all that up. So now, instead of my cutter being in front of the pin, it's going to be behind the pin. So if this thing flexes, and also we're going to have some built-in flex in this whole S-shaped thing here that will, again, if the shaft bends, it's going to bend back and give me clear, where it'll be swinging out rather than into the work. So that's kind of my game plan. And as far as making that, I think what I'm going to do is I got to make a couple of phone calls. I know that I've got a place that can flame cut on a CNC machine some 1-inch material. And I'm thinking about actually cutting 2 pieces 1 inch thick, and then welding them together, maybe even bolting them in some places to make them really a 2-inch wide piece, probably 2 inches in this direction as well, just to make it nice and rigid. And then I'm going to have to machine and put it in the bottom, a place to hold a cutter, kind of like this, to hold my tool. And then I can do it in different positions. That's kind of what I'm thinking. And again, here, I should have enough clearance when that Stoker body kind of comes in. You know, that's kind of illustrating the bottom of the thing, but this will actually come out over the top of the Stoker engine, give me the clearance that I need to get back there, still have my cutter where it can come out, clear the front, and not run into it up here. That's what I'm thinking. And I need to go over here and get some measurements and actually figure out exactly how I want that piece to be and how long it's got to be and everything else. And I think I'm going to work on that right now, and then I'll probably draw it up in CAD, at least draw the profiling CAD that I can send a file over to them to cut me out a couple of pieces. But that's kind of what I'm thinking. Is it going to work? Well, I think it has a lot better chance of working than what we got right now, and time will tell. This is just kind of trial and error. There is no probably out of, just an off-the-shelf solution to the problem that I'm dealing with because of the constraints of the space that I'm working in. So we're just going to have to make something and make it work. That's what I'm looking at. All right, after some measuring and finagling and figuring and everything else, I've kind of come up with this design that I want to make. And basically this is just showing what needs to be cut out with some dimensions, and you kind of see there's a little isometric view of what the tool will look like down there at the bottom. It needs to be 2 inches thick, and I have sent a message over to my shop that I work with that does some cutting for me. That can cut. I know they can cut 1 inch. I don't know how thick they can cut. If I have to, I can have them cut 2 1-inch pieces and weld them together to make a 2-inch wide or thick piece. I'm waiting to hear back from them. I just emailed them the drawings and DXF files and all that, and I'm going to see what they can do. And once I hear back from them, and we will get some parts and see what we can do. Now, my idea down here on the bottom as far as the tool holder is concerned, let me show you what we're going to do. So I've got this Armstrong type planer tool holder right here that has this piece that fits down in there. So basically what I'm going to do is I'm going to just adapt it where I can put this tool holder into this that I'm going to make, and we'll just have to, the bottom end down here, we're going to have to machine to look like this. And that shouldn't be a problem to do here once we kind of get all that done. So we will make it where we can go down there. And again, this takes a 1/2 inch high-speed steel tool cutter. That's not a 1/2 inch, but it fits in these different positions depending on which one you want to use. Clamps it from the top, bolts it from the back. I'll have about a 1/2 inch clearance from the front of the tool to the part, so I should have enough clearance. It's going to be really tight. 1/2 inch is not much room for error, but it should be enough to get the job done. And anyway, that's my game plan. We're going to give it a try, see how it works. I think it'll work. I've been wrong before, but we're going to give it a try and see how it goes. That's my game plan. So it's been a couple of days. I sent this over to my guy down in Valdosta that can flame cut this stuff, and I sent it to him on a Monday afternoon, and I picked this up on a Wednesday morning, and he actually was able to cut it out of some 2-inch thick stock. So this is all one solid piece. Very, very nice. So now what we need to do is start working on machining this down here at the bottom to basically look kind of like that. Need to round out the corners, bore the hole in there, and mill in the crosses on there, what have you. There's also a little bit of a recess on the back side so that it will accept this little cap piece here. And I'm going to recess this back as far as I can in here within reason to make sure that I'm getting that cutter moved as far back on this as I can to where it doesn't dig in. So I think for the machining, what we're going to do is we're going to do this over on our Kearney Tracker 2D mill, the rotary head mill. Since we got some rotary work to do, I think it's going to be the easiest place to go do that. So let's get that machine set up and we'll start working on putting those features in there. Well, guys, I think this is going to be kind of a stopping point today. I've got the part in. We're ready to go over to the milling machine and start doing the milling, but I spent so much time kind of talking about the whole situation, really didn't leave time to actually make the part. So we'll come back and do that again here real shortly, but I did want to take the time and just kind of bring you guys down this whole journey and kind of share with you some of the problems, because, like, again, got an awful lot of comments, an awful lot of really good suggestions that under normal circumstances would have been great suggestions, but because of the constraints that I'm working with over here, again, it's a challenging situation, and we're having to just kind of be creative to come up with a solution. I'm hoping this is going to do. So when we come back in the next video, we're going to actually do the machining, get that cutter ready, get it mounted, and hopefully get it tried out. So that's going to be coming up soon. Guys, with that is going to be a wrap. As always, thanks so much for watching. Please subscribe to the channel if you haven't already. Those thumbs up and comments are greatly appreciated. Please hit that bell icon up there to get notifications when new videos are posted. And as always, a big, huge thank you to those who support the site financially through Patreon, PayPal, etc. There's links for that down below in the description, and it really does help out and enables me to take the time to shoot these videos and do all the editing and everything else that goes along with it. So with that, we're going to get out of here. We'll catch you guys on the next video. Again, as always, thanks for watching.